It's recording.
Is it recording?
Yes.
Okay. I guess do we all need to be like in front of them?
Nah, I don't need to be up there, I don't think. Just say your names. This
Have
is
we
video.
start?
Huh?
Have we start?
Yeah, sorry, just say your names. We don't have to be staying here.
Alright, this is Engine 20, Goose presentation. This presentation, my name is Caden. I'll be presenting the crankshaft. Later on, you'll have Matthew presenting the connecting rod. After that, we'll have Micah with the piston, and then finally we'll have Khalil with the camshaft, timing gear, and our prototype connecting rod. Alright, for the crankshaft, I first started with this sketch, and I used the revolve tool to create the cylindrical shapes without having to do each one individually. After that, I created the disc portions that you see here and here. I first created one, then I mirrored it across to the other side of the crankshaft. And after that, I extruded the cylindrical shape across between two counterweights. Following that step, I cleaned up the two circular cuts you saw earlier. I added the slots, the hole, and the two circular, semi-circular cuts in the back of the shaft. For the fourth step, I threaded the end of the shaft with the hole wizard tool, and then I used the thread tool and toolbox to make the threads on the end of the shaft. For the fifth step, I cut out the left counterweight. I first cut this section out, and then I cut the last circular section, and to create the angular shape you see here, I cut one extrude going that way. For the sixth step, I did the same thing, just on the right side. But instead of using extruded cut that way, I use a cut sweep tool to create this curve, as you see there. And for the seventh step, I added chamfers and some various fillets to smooth it all out and make it look like the actual part. Following this, we got a few crankshaft views. You can see here is the top view, one is the few side isometric views, and one rear view, so you can see the threads at the end of the shaft. With that being said, I'm going to hand it off to Matthew with the connecting rod.
Hey, I'm Matthew. I'll be presenting the connecting rod. For the connecting rod, there's actually two pieces, so I'm going to first present on the bottom larger piece. And as you can see, I first created a sketch, and this was on the front plane, and then I used a mid-plane extrusion to get this extruded piece right here. Next, I created a sketch once again on the front plane, and I actually used the mid-plane once again and did two different extrusions from the same sketch to get two different widths, as shown right here. I then added the holes and the chamfers and the cutouts, as shown in the left picture right here. I also created these right here, the curves, to add more shape to the piece. I then added the cylindrical extrusions, and this will help with the next side cutouts, as shown right here. I created these cutouts by actually using the the offset feature, and I used geometric relations to make them tangent to the extrusions, along with adding the arcs. I then used a blonde cutout to get the depth. And then to finish the part out, I added the threads, fillets, and chamfers. For the second piece, the upper part, I did pretty much the same process. So I started out with the sketch, and I did that one once again on the front plane, and then did a mid-plane extrusion. I then added two cylindrical extrusions and a rectangular extrusion. I then also added the holes and the cutouts, and then to finish it off, I did the fillets, the chamfer, and added the cracked edge, as shown right here. And then I added in right here, I have the front view of the two pieces that I made in an assembly file, the top view, the isometric view, and then just a secondary view with a little bit more detail shown. I'll give this to Micah to continue the presentation.
My name is Mike Sheffield, and I was responsible for modeling the piston. And to start with modeling the piston, I basically just had a sketch of a cylinder and I extruded it upward to the right length to create the outer shell of the piston. Once I had the outer shell, I started by making circular cuts around the top, and then also I had to shave the sides to get the right width. Once I had that, curb cuts were needed to be added to the bottom of the piston and extruded upward, along with a cut along the base of the piston right here. Chamfers were then added underneath these piston rings. I added them a little early, that way I could get more precise measurements and cuts. Once I was done with the outer shell, I was able to do the inside. To start with the inside, I did the shell feature to the right depth. Once that was done, I added this extrusion right here along with a hole that the gudgeon pin could sit in and go through. I then finished up with small detailed cuts on the outside of the piston and used the mirror feature to mirror it to the other side to make the piston symmetrical. Once symmetrical, on one of the extrusions, this one right here, I added a stopper so that the gudgeon pin wouldn't slide straight through the piston. Finally, small details were added on the inside and fillets and chamfers to finish the piston. Also, I had the gudgeon pin. The gudgeon pin was quite simple. All it needed was 2 circles and an extrusion, and then chamfers were added on the edges to finish off the gudgeon pin. I'm going to hand it to Khalil now and finish the presentation.
My name is Khalil and I had the camshaft. For the camshaft, I decided to split it up into separate parts. I started out with the main shaft. For the main shaft, all I did was make this simple sketch on the front plane, and I did a revolve. With this sketch, instead of adding the chamfers after I did the revolve sketch, I decided to add the chamfer into the main geometry by adding this dimension and this dimension. And here you see after the revolve sketch, after I got the revolve done, I added this hole here. This hole is for the small pin that includes another attachment. After that, I started on the camshaft sleeve section, which included the cams. Here, I built it from the bottom up. I started out with a small extrusion and added up section by section, as you can see here. And once I did that, I used an extruded cut to get the shape of the cams and also to get the shape of this midsection here, as you can see. The next thing I did was the main gear that attaches to the main shaft of the camshaft. And with this part, I used the toolbox to create the gears. With this, for the toolbox, I had to insert the diametral pitch to get the right geometry. To do that, I had to find the pitch circle. I did that by taking the diameter of the gear, including the teeth, and then taking the diameter without the teeth. And I took the average of these diameters to get the pitch circle. And once I got the pitch circle, I divided 42 teeth by the value I got for the pitch circle, and that gave me the diametric pitch, which I then inserted into the toolbox, and that gave me the correct geometry. After doing that, I added these cuts, as you can see here, and I added even more geometry, some extrusions, as you can see right here, and here, as well as a few more cuts, as you can see right here. The next part I did was a small pin that attaches to the main shaft. And for the small pin, it was just a simple sketch, and I did a revolved extrusion, as you can see here. For the attachment piece, that was a little more complex. For this piece, I started off with this boss extrusion, as you can see here, and I added a sketch here, sketch for a cut extrusion. And after I did that, I got this shape. Before I actually got this final part, I had to add this piece here using extrusions and various cuts. And after that, I added fillets to get this final part here. This part I made, this wasn't actually attached to the camshaft, but this was the timing gear. For the timing gear, I did the same thing I did as for the gear on the main camshaft. I used the toolbox and found the diametric pitch to get the right geometry, as you can see here. Then I added these chamfers and this cutout to mirror the actual part. After I had all the parts made, I put them into an assembly, as you can see here. The main gear, the sleeve section and the main shaft, as well as the small pin and the small attachment. Here are different few views, and I also added more chamfers to this main gear that I didn't add before. And I used the right geometry to get the parts where they needed to be in the assembly. And here's another bottom view where you can see the angle between each camshaft. Next is the prototype. From the original part, some things we changed were we took away this curvature here and made it straight, as you can see here. We also decided not to do this H-beam type section, and we took away these extruded holes and made this here. We also made this beam here more narrow, just to save space to make the rotating mass a little better. Also, we took away a lot of the original material to make it more manufacturable, and we took away these curves to make it a more simple shape, also making it more manufacturable. In our final project, we will include this slide, but right now we don't have it.